Okay, so a quick video on completing the square, as a lot of my tutees ask me about this topic. So um, everyone, I think, knows what a square is. I will just sketch one out. You can see here, right? So let's say that's 3, that's 3. So the area is 9. Very straightforward. Imagine if instead of having a value of 3, we have, let's say, x plus 4. Well, the other side must also be x plus 4, mustn't it? Right? But to work out the area in that case, it would be x plus 4 multiplied by x plus 4. Okay? If you multiply that out, you do the x times the x times the 4 times the x, and the 4 times the 4. So you end up with x squared, 2x and 2x, so 4x overall, plus 4. All right? And if I were to pick another example, let's say x plus, I don't know, 7, and we were to multiply that out, it's the same thing. You'll end up with x squared plus 14x plus 49. All right? So if we have a square, we have a relationship between this term and this term, right? There's an invisible 1 there. So the a term here is 1, the b term is 14, and the c term is 49. Okay? So when we have a square, to get from the b to the c, we halve it, and then we square it. It's a bit hard to write, but you get the idea. Okay, so in this case, look, we took 14. If we halve it, we get 7. And if we square it, we get 49. That's the path. So squares will always have this relationship. Well, completing the square is if we don't have that relationship, but we kind of force it, so to speak. So if, for example, I have, what could we say? X squared plus 6x plus 1, right? Well, that isn't a square, is it? My c term, ideally, at the moment it's 1, ideally it would be 6 halved, which is 3, plus, squared, which is 9. Okay, or we don't have that. But what you can do in maths, you can add something in, provided you also take it away. That's in keeping with the laws of maths. So I've created a 9 from nowhere and I'm taking 9 away. So it hasn't actually changed the overall thing. And then all I have to do is group all of that stuff. Okay, I've maybe not done that in the best way, but that's going to give me x plus 3 squared. All right? Because that's my ideal c term that will give me that. The other stuff is then kind of left over. Right? So I've got the plus 9 and the plus 1 and the minus 9. So my final answer, of course, is minus 8. Right? So I've got, it's a bit hard to see, but x plus 3 squared minus 8. Okay? You might say, what's the point in doing this whole thing? Well, it just so happens that we can use this to work out the turning point. So if I were to have the graph y equals x squared plus 6x plus 1, right? It just so happens that I can get that is my y coordinate, and my x coordinate, the bracket, is equal to 0. So my x coordinate is minus 3. All right? So minus 3 minus 8, about here, would be where this graph, it's its lowest point. It's the minimum point. All right? So that's the reason we do it.